Alfalfa is a very important forage source for Montana. It is a $500 million industry, and it is a preferred forage because it does gives us high yield and quality. So this study is funded by the U.S. Department of Agriculture in collaboration with 3 other universities: UC Davis, University of Florida, and University of Arizona. There is an evidence with the climatic simulation done by our colleagues at MSU Bozeman that the growing season for this region is actually extending. Our fall is a bit warmer than normal. And what it means to us producers is that there might be an opportunity to plant fall dormancy that is less dormant compared to the more dormant alfalfa varieties that we usually plant. We used 3 fall dormancy number 2, number 3, and number 6. This is important for us to test fall dormancy number 6 because this is outside of our usual choice for alfalfa genetics. This experiment has been under 3 moisture regimes. One is rain-fed, one is 100% ET or irrigation where the plants don't experience any stress. And then another one is 50% evapotranspiration where we basically cut off the irrigation from 100% ET into half. We scheduled it in the same day, but we only apply half in the 50% ET relative to 100% ET. So as I said, this is on the 3rd year of study, and our initial finding really is that the yield on the rain-fed ground, all of the fall dormancy are basically similar. On the 2nd year, fall dormancy number 2 was a bit more advantageous on the rain-fed ground. However, when we applied irrigation to these varieties, to these genetics, the fall dormancy number 6 consistently produced more yields than others, with a caveat though, that there's one fall dormancy number 6 that is inferior to the rest of the genetics, and that is fall dormancy number 6 that has low lignin. As I said, this is on the 3rd year, and you'd be happy to see that fall dormancy number 6 is actually surviving. So this plot over here, this is fall dormancy number 6, Cisco 2, here. And this is fall dormancy number 6, which is the High-Just 660 low lignin. And as I mentioned earlier, the Cisco 2 regular fall dormancy number 6 yields much more than the rest of the genetics, and that is something that I never expected. However, as I said, fall dormancy number 6, which is a High-Just type, is inferior relative with the other genetics. Now here, this is fall dormancy number 2, and also this is fall dormancy number 2, and this is fall dormancy 3. So Eeusha Nafi, he has the skill set to doing simulation technique in order to utilize the stored data set that we have and make more sense using simulation technique and have more answers to some of our questions.
Hi, my name is Eeusha Nafi, and I am a postdoctoral research scientist at Northwestern Agricultural Research Center. I'm mainly working on crop simulator, which means I'm assessing the future climate change effect on crop growth. So one of the many aspects of climate change is the ongoing rise of temperature. The rise of temperature affects the crop growth in many ways. Another thing of climate change is the change in rainfall intensity. So how we can assess the impact of climate change on crop growth. One of the important tools that we use is the crop simulators. A crop simulator is a computer-based program using different mathematical equations that mimic the crop growth and development and try to grow the crops virtually. For this purpose, we use regional data like weather data. We use information like soil information, and we also take information like the management practices. So why we're using crop simulators? What is the significance of it? So one of the most important aspects of using crop simulators is the farmers as well as the strategic decision makers can have valuable, affordable information in a timely and a cost-effective way.
So, based on the 3-year data, we find that fall dormancy number 6 continued thriving in Montana cold condition. And that is a good thing to document. In fact, some of the prominent agronomists and breeders have a consortium that the selection for winter survival in the northern region or in the cold region of the United States is actually a winter survival rating and not so much on the fall dormancy rating. So we documented that here in our research. So for that, I have a 2-year data that's available for you, and if you email me, feel free to do that, and I'd be glad to send you a copy of the 2-year performance data, and we will continue to monitor and provide you with yield on the 3rd year of data, which is this year.